Hello everyone, myself Sheetal Dhumne, working as Assistant Professor from Indian College of Engineering. Now in this video we are going to discuss about the block diagram architecture of 8051 and memory organization of 8051. In the previous video we have seen the features of 8051, family members of 8051. Now we will discuss the block diagram of 8051 microcontroller. Now this is a detailed block diagram of 8051 microcontroller. It's having the 4 ports, port 0, port 1, port 2 and port 3. Now these ports are multifunctions. Your port 0 is having A0 to A7 input output port. That is address lines are there. Your A8 to A15 address lines are with your port 2. Latches are provided with your all the ports. Your internal RAM structure is divided in 2 128 bytes. These are your special function registers. This is having the size of 128 bytes. While your general purpose registers in your bank, they are having 128 bytes of memory. It's having 4 kilobytes of ROM. Then it's your special function register RAM. PSW, that is program status word, that is nothing but the flag register. Arithmetic logic unit is used for your arithmetic and logical operations with the help of contents of ALU and any other registers. This is accumulator, this is the B register. Program counter and DPTR, these are the two 16-bit registers are there in your 8051. So this is the general block diagram of your 8051. It's having 8-bit data bus and 16-bit address bus. As it is a 8-bit microcontroller, your data bus should be 8-bit. Special function registers in 8051. Accumulator and B registers. Each register is 8-bit each. So they are used for your arithmetic and logical operations. The special function of this register is that for your multiplication and division instruction, your data should be always stored in accumulator and B register. We cannot store the data in any other register, general purpose register for multiplication and division instruction. DPTR, it is having the it is divided in two 8-bit registers as DPH and DPL, that is 16-bit combined. Program counter is 16-bit register. Stack pointer is 8-bit register. Program status word, that is nothing but the flags that are set after the operation, that is also a 8-bit register. It is having the serial data buffer, timer registers and control registers. Accumulator, just now told you that almost what are the result of each operation will get always stored in your accumulator. Almost all the data transfer and arithmetic instructions involve accumulator. Can be referred to several ways implicitly in opcodes, referred to as accumulator for instruction that specifying a register. By its special function address, this is the address the defined in your 8051 for accumulator, that is the 0E0. It is a bit addressable, that means you can change a single bit of your accumulator. For example, if you want to change the third bit of your accumulator, that means ACC.2 means bit 2 of your accumulator register will get changed. It depends on that how you can define the bits, whether you start with the 0 or you start with the 1. That will be your LSB or MSB, how you are defined. B register is not frequently used. When it is used, it acts as a temporary register, much like a 9R register. I just told you that these two instructions, multiplication and division, they should require the data always in A accumulator and B register. Your B register holds the second operand initially and will hold part of the result after the execution of instruction. It is also a bit addressable register, B register. DPL and DPH. Two 8-bit registers that can combine into a 16-bit DPTR, used as a data pointer to access external memory. That means if you want to store the 16-bit data in, then you can use this DPTR register. That 16-bit data will get stored in DPTR with the help of move instruction, and that will be actually split in DPH and DPL, 8-bit. It can be accessed as a two separate 8 bits also. Just now I told you can directly store the 8-bit data in DPL or DPH with the help of instruction move instruction, move dpl hash data, or you can have move dpl hash data. Stack pointer. It points to the last used location of the stack. Push and pop operations are related to your stack pointer. Your push operation will first increment the stack pointer and then copy the data, while reversing your pop operation, pop operation will first copy the data and it will decrement the stack pointer. In 8051, stack grows upwards from low memory to high memory and can be in the internal RAM only. On power up, your stack pointer always starts with the point or always has the address of 07. Your register banks 2, 3, 4, 08 to 1F from the default stack area. It can be relocated by setting your stack pointer to the upper memory area in 30 to 7F. That is also possible. Program status word. Now this is nothing but your flag structure of your 8051. That means after the execution of your instruction, whether your carry flag will be set, whether any auxiliary carry flag will be set, any overflow will be there, or any parity flag will be set. So that your setting of your that particular flag that can be observed or that can be done with the help of your program status word. So this is the standard format of 8-bit format of your program status word. This is your carry flag, auxiliary carry. This is user defined, that is not defined, RS1 and RS0, overflow, that is the reserve, and P is for parity. Now this first is carry flag. So after the arithmetic operation, if any carry flag will be set, that automatically this flag will be set, carry flag. Auxiliary carry flag, that is whenever you get the carry from lower nibble to upper nibble, then we can say that your carry flag, auxiliary carry flag will be set. Next is F0, available to the user for general purpose. Next is RS0 and RS1. These are the bank select registers. You know that there are 4 banks are there in 8051, bank 0, 1, 2 and 3. So whenever you want to select the bank, then it depends on these 2 bits. According to that, you can select the particular bank. Suppose you want to select the bank 3, then your RS1 and RS0 should be 1, 1. If these bits are 1, 1, then you can automatically your bank 3 will get selected and the registers from your bank 3 will be used for your further operations. Next, overflow flag. Whenever your data will get overflow, so this flag will be set. Then next, the reserve portion and parity. Depends on your odd and even parity, that particular bits will get set and reset. This is the RS0 and RS1. Just now I told you that if these bits, 2 bits are 00, bank 0 will get selected, that is addresses from 00 to 07. 01, bank 1 gets selected, 08 to 0F. 10, this bank 2 will get selected from addresses 10H to 17H, and bank 3, that both the bits should be 1, 1, then your addresses 18H to 1FH will get selected. Carry flag, this flag whenever after you get the carry out from your D7 bit, auxiliary carry, your upper nibble to lower nibble, you will get that particular carry flag. Parity, then odd parity of is then P is equals to 1, otherwise it is 0, and overflow flag. Programmer's view, that is memory organization, register set or instruction set, and hardware designer's view is that is you should require the knowledge of pin configuration, timing characteristics, and how much current and voltage requirements are there for your hardware, that is a chip. This is the memory organization of your 8051. It has a separate address spaces for program storage and data storage, as it's having the hardware architecture. Depending on the type of instruction, the same address can refer to 2 logically and physically different memory locations. So this is your external data memory. It starts at address 0002 FFFH. These are the special function registers and internal data memory. So your internal data memory starts at 00 to 7F, and your special function registers are from 80 to FF. This is the program memory. It is internal memory from 00 to 0FFF and 1000 external to 1 FFFF. So this is the same that we have discussed. 128 bytes of RAM. It's having a 4 kilobytes of your ROM is there in your 8051. It can add memory externally, that is 64 kilobytes of memory can be addressable with your 8051. Internal also and external also. This is the internal RAM organization of your 8051. These are the working registers, that is your banks. This is your bank 0, bank 1, bank 2 and this is your bank 3. So each bank is having 8 registers R0 to R7 and that starts first bank as 00 to 07. This is the bank 0. These are the working registers. These are the bit addressable register. That means from this area, that addresses are defined for any registers, that we can change a single bit of that particular registers. And this is the general purpose, that is from 30H to 7FH. So this is the in general internal architecture or internal memory organization of your 8051. Program status word, we have discussed that already. So this is the internal data space of your data memory of your 8051. So depending on the bank selection, that depends on 2 bits, that is you can select a particular addresses for that. So in this diagram you see this is shown that this is the reset value of stack pointer 07. This is the bank 0. So by default whenever you power on the 8051, then your bank 0 will get selected and your stack pointer will be point to the 07. This is the bank 2, bank 3 and bank 2 and bank 3. These are the bit addressable area and this is the general purpose area. So your bank selection will be always depends on your 2 bits in your PSW, that is RS0 and RS1. Internal ROM, the size of internal ROM is 4K. It address space from 00 to 0FFF. Program addresses higher than 0FFF will automatically fetch code byte from external program memory. That pin should be grounded, then only you can access the external memory. These are the references for your 8051. You can use directly the datasheet of 8051 microcontroller, or there is a good book for your 8051 microcontroller, that is by the author Mohammad Maziri. Okay. So all of you refer these references for this. Thank you.